Hi, math students. I'm Miss Carol. Hopefully you've seen a video or two of mine by this point already. But what I'm going to do for the projects this quarter is I'm going to actually walk through them on video. And so you're basically going to get participation points for completing the projects because I'm going to be doing them with you. So if you simply listen to these videos that I'm recording, you should have all the information that you need to successfully complete each project. So let's go ahead and get started. This is for Unit 1, Lesson 1, and I'll go ahead and read this. It says, someone has turned off all the power in the town of Brightland and stole the keys to the power plant. However, like most inexperienced criminals, they left behind a series of clues that could lead you straight to them. This particular perpetrator decided to be clever and left clues that require you to simplify expressions using exponents and powers in order to turn the power back on. But any wrong answers could mean that you end up apprehending an innocent suspect. Carefully work through the problems to catch the real culprit. Okay, so this first problem wants us to simplify this expression. All right, and I'm going to go ahead and pop it out. 6 to the 4th times 6 to the 9th, all over 6 cubed, and then the entire expression cubed. So let's go ahead and work through this. I'm going to do what's in the parentheses first, and then I'm going to take care of the outside. So I've got 6 to the 4th. Well, maybe this will work and maybe it won't. There we go. 6 to the 4th times 6 to the, let's try that one more time. 6 to the 4th times 6 to the 9th over 6 cubed and all to the 3rd power. So my first step is going to be combining 6 to the 4th and 6 to the 9th. Since these are the same base, I can add my exponents. So I've got 6 to the 4 plus 9 over 6 to the 3rd. Okay, and still all to the 3rd. This becomes 6 to the 13th over 6 cubed, all cubed. Okay, the next step is I'm going to combine the numerator and the denominator. Again, I have the same base, so I can subtract the exponent in the denominator from the exponent in the numerator. So I'm going to have 6 to the 13 minus 3, all to the 3rd power, and this becomes 6 to the 10th to the 3rd power. Okay, so the trick here is that we can multiply these. I have a power to a power, and I know I can multiply them because if I were to write it out, I would get 6 to the 10th times 6 to the 10th times 6 to the 10th, which is 6 to the 10 plus 10 plus 10, which is 6 to the 30th power, and 10 times 3 is 30. So I know my answer here is 6 to the 30th power. So the first name of our culprit is going to be Irvin. All right. Now let's find the last name of our perpetrator. And we have to simplify this expression. Okay, in this case, I might do a couple steps at the same time. I'm going to combine my x to the negative 11 and x to the 5th in one step. And I'm also going to take my x to the 4th and my y to the 4th. So it's going to look like this. X to the negative 11 plus 5. I can combine those because they're the same base. And then this is still times x to the 4th over y to the 4th. Okay? Whatever is inside the parentheses that are being taken to a power, everything within those parentheses has to be taken to that power. Okay, so next step, this becomes x to the negative 6. A negative 11 plus 5 is negative 6 times x to the 4th. And that's all going to be over y to the 4th because I'm multiplying those. Okay. Next step is combining these two. So the same base, I can add the exponents. X to the negative 6 plus 4 over y to the 4th. So I get x to the negative 2 over y to the 4th. So let's look at what my possible answers are. I might have to change the format just a little bit. Let's see. I can change this to a x to the negative 2, y to the negative 4, because if I have a positive exponent in the denominator, if I want to move that variable or number up to the numerator, I just have to change the sign of the exponent. So x to the negative 4th is the same as 1 over x to the 4th, or y to the negative 4th is the same as 1 over y to the positive 4. So these two quantities here are equal, which means that the last name of our culprit is Morton. All right. So let's see. This is going to simplify, as we've already decided. This is one way to write it. Another way to write this would be 1 over x squared y squared. If I wanted to move, y to the 4th. If I wanted to move both variables into the denominator, I just have to switch the sign of the exponent. So that will work. And let's see. We decided that it was Morton. So we want to click on Morton. Okay. So we've got Irvin Morton. And on the last question here, we team up with a partner, Daniel, to solve the last problem. Because it's going to reveal the location of our culprit. And we need to simplify this expression. Okay, 5 to the 12th times 5 to the negative 4th. All right, so that's not too bad. That simplifies to 5 to the 12 minus 4, which is 5 to the 12 minus 4 becomes 5 to the 8th. Okay, and then in my denominator, remember, I can just multiply these. I've got a power to a power. So this becomes 5 to the 6th power. Okay. And now I can combine these two because I have the same bases. I can subtract the exponent in the denominator from the exponent in the numerator. So I get 5 to the 8 minus 6 is 5 squared. Okay, so it looks like, according to this, the culprit is in the library. So Irvin Morton was in the library, or is in the library, and he is our culprit who stole the power. Okay, so we know that. Now, in order to answer this question, we have to take a step further. Daniel solves the problem by first simplifying the numerator, which we did. The bases of the powers have the same base and are being multiplied together. He applies the product of powers rules and adds the exponents to 8, so that's exactly what we did. Then he simplifies the denominator. He applies the power of a power rule and adds the exponents to get 5 to the 5th. Whoop. Sometimes, there we go. So he got 5 to the 5th. Remember, we got 5 to the 6th. So the difference was that we multiplied our exponents and he added them. So if he were to do this, 5 squared times 5 squared times 5 squared, then he could add them. Okay, 2 plus 2 plus 2 is 5 to the 6th. Okay, but he just added them straight across where we multiplied them, okay? So we ended up getting 5 squared, and his final answer was 5 cubed. So they go ahead and they tell us that his response was incorrect, and so they want us to explain what he could have done differently to get the correct response. So we would just go here and we would say, instead of 5 to the 5th in the denominator, he should have 5 to the 6th because we multiply power of powers instead of add them. Okay? And that would be a totally sufficient answer here. And that's all you need to do for Unit 1, Lesson 1. Thank you.